Clever young guys, very good evening. We are here with math exercises. We are going to see an example of derivatives, specifically to know how does logarithmic derivation works. So, we have here the f function equal to cosine of x squared plus 1 multiplied by sine of x multiplied by square root of x squared plus 3 multiplied by x to the power of 5 multiplied by tan of 3x squared. So in this case, in this exercise, we need to take the derivative of our f function. There are many ways to do that. If we wanted to do it by the ordinary formula that says that the derivative of the f function in this case will be u multiplied by the derivative of v plus v multiplied by the derivative of u, then first of all, we need to consider cosine of x squared plus 1 as u, and then sine of x as v. Apply this formula and the result will be u, and this factor will be v. Then going on and on, this result will be u, this factor will be v, this whole result will be u, and then at last, this factor will be v. So if we do this way, it will be a very large process, and believe me, we are going to end tomorrow. So we are going to use the logarithmic derivation, that is a technique that is used to take the derivatives of a function that, as we can see, has lots of products, and then we are going to see it. So first of all, we need to know that the derivative of a function inside of a natural logarithm will be 1 divided by the function, and then by the chain rule multiplied by the derivative of the function. So if we clear the derivative of the function from this whole expression, then we will have that the derivative of the function will be the derivative of the function inside of a natural logarithm multiplied by the function. I'm going to put it this way to have very present that formula. So first of all, we need to know this factor, and then we need to multiply by the function itself. So for knowing this factor, we need first of all to put the whole function inside of a natural logarithm. That will be natural logarithm of cosine of x squared plus 1 sine of x square root of x squared plus 3 x to the power of 5 tan of 3x squared. Okay, we have. So in this case, we are going to remember the logarithm properties, that one of them says that the natural logarithm of a multiplied by b will be natural logarithm of a plus natural logarithm of b. So remember that we can apply these properties if the logarithms are on the same base. In this case, we know that natural logarithm is on the base e, so we can apply this formula inside of these whole products. We're going to do it. We're going to do this, and will be like this: natural logarithm of cosine of x squared plus 1 plus natural logarithm of sine of x plus natural logarithm of square root of x squared plus 3 plus natural logarithm of x to the power of 5 plus natural logarithm of tan of 3x squared. Okay, so now we have applied the logarithm property. So in that case, we're going to apply, for example, in this case, we're going to apply another logarithm properties, that will be that if we have, in this case, natural logarithm of a to the power of b is the same as having v multiplied by natural logarithm of a. So if we apply this property on this one, remember that we have the square root of x is the same as having x to the power of 1 divided by 2. So consider these two properties, we can put this in another way. So let's do this. So I'm going to rewrite this whole expression. Here we go. Fine. So, as we see here, to take the derivative of a function inside of a natural logarithm, we need to put the function dividing a1 multiplied by the derivative of the function. So if we apply this formula inside of these whole factors, then we are going to take the derivative, first of all, this factor, for multiplying by the f function and then taking the derivative of the f function. So we're going to apply this formula. That will be, in this case, let's remember that we have a 1 in here. You don't put it, but you know that it's a 1 in here. So we put 1 divided by cosine of x squared plus 1 multiplied by the derivative of this whole function. That will be minus sine of x squared plus 1 multiplied by the derivative of this function, applying the chain rule, 2x. So I'm going to put it, so if we multiply these two ones by 1, then we will have this multiplication. I'm going to put it in here because I don't have much more space. Let's see. So in this case will be 1 divided by sine of x multiplied by the derivative of sine, that will be cosine of x. I'm going to put it again here, plus 1 divided by 2 divided by x squared plus 3 multiplied by the derivative of this function, that will be 2x. Then 2x multiplied by 1 divided by 2 will be x, and then in this case we will have 1 divided by x to the power of 5 multiplied by the derivative of x to the power of 5, that will be 5x to the power of 4, and then we multiply 5x to the power of 4 by 1, we will have power of 4 plus 1 divided by 10 of 3x squared multiplied by the derivative of this function, that will be second squared of 3x squared multiplied by the derivative of this function, that would be 6x. So if we multiply this one by 1, we'll have sec squared of 3x squared plus 6x. So now we have this factor, we have taken this factor, and the only thing left is take the derivative of the f function. So sine divided by cosine, we know that is a tangent of x squared plus 1 multiplied by 2x plus cosine divided by sine will be a cotang of x plus, there's no more to do there, plus 5 squared over squared So, I really don't have any more space in here, so I will put that we will multiply this whole function by the original function, that will be our f function that we know, that is this one. I cannot put it more there because I don't have any more space, but you know that this f function will be this one. So we have taken the derivative of our f function. Remember, for this kind of exercises, knowing very clear the formula to take the derivative of a function inside of a natural logarithm, and also knowing very well the logarithm properties so you don't make any mistake in this whole process. Thank you very much for your attention. Remember visiting my Facebook. You can put me there if you have a doubt. If I know how to solve it, then we will see it on this space. Also remember visiting my blog. I have math essays there, physics essays and geometry essays, and a little bit more. Thank you very much.